All right, y'all, this is going to be Unit 6 review FRQ number 3. I do have the link in the description to this video. Find FRQ number 3, and it'll give hints based off of the textbook, The Practice of Statistics, 6th edition, for the page numbers. Let's read through the problem. Amazon.com is one of the largest internet-based retailers in the world. The company offers a Prime membership for a fee, which provides certain benefits for members. A recent report states that 46% of U.S. households have an Amazon Prime membership. Penelope wants to know if this proportion is different for her large hometown. She selects a random sample of 80 households from her hometown and finds that 43 of them have an Amazon Prime membership. Is there convincing evidence that the proportion of households in this town differs from the claim in the report? And like the previous problem, of course, you would not know what this type of proportion is, or what type of test or interval this is. So you have to read through the problems and infer about what it is. How many proportions are we taking? Just one, right? We got one random sample, and we're trying to provide convincing evidence. So we need a p-value, okay? So anytime you need a p-value to convince something, we have to run a test. So pause the video and see if you can do a one sample z-test for p, and then after you unpause it, you can check the solutions here. All right, time to go through this. This is a one sample z-test for p. Make sure you name it. We are not given an alpha level, so we want to just kind of put a generic 5% if you're not given one. Always set up your hypotheses. So it's, remember, ho-hop, and it's always p, not p hat for your number. So for the symbol you put on here. So always just put p on it. Define p, the true proportion of households with Amazon Prime, and calculate that p hat. In this case here, we're actually given that we're going by this report that 46% have Prime, and the sample was 43 out of 80. So if we calculate that, we get 53.75. Now we have some evidence that the proportion is different, but do we have convincing evidence it's not different? And one other thing, we want to make sure we use not equals, because when you see that word differs, that's not equals. It's not greater than or less than, it's just different. So let's go to the conditions. It's going to be your random 10% and large counts. Same as in an interval, random sample of 80 households. 80 would be less than 10% of all households. Your large counts, you want to use your null, okay? So we always assume the null is true. So we want to use the 46% for those. If you do those calculations, both of those are going to be greater than 10. So we're good, safe to say we can use a normal curve on it. Next thing we want to calculate is our z-score. And you can use your standard deviation formula. Remember to use the null for the p, not the p hat, because we assume the null is true. Plug those in, you get about 1.391. When you do a normal CDF or use the table, you're calculating the value that z is greater than that, which is about 8.2%. Since this is a not equal, we do want to double that to get the other side. So we have the positive and the negative, and together you get a p-value of about 0.164. You also want to make sure that you can do this on the calculator, because if you get the formula on here, you can still get this answer. So when you go to the calculator, go to stat tests. This is the one prop z-test, 5. And in here, you're going to put your null proportion, 0.46. You're going to put your counts out of 80, so 43 out of 80, and set it to not equal. I like the draw feature. That gives you some more visualization of what's going on. And notice that when it's a two-sided test, it does give you both shaded regions, the positive and negative. So while z is a positive value, it's not only calculated in the area above 1.39, but also below negative 1.39. And that combined is about 16.43%. So it'll automatically give you the doubled p-value. No need to double it if you're going straight from the calculator. These are the two most important things to have on your do part. So at the end of the day, you need to have z, you need to have p. If you don't get the formula down, not the end of the world. And finally, based on our conclusion, well, that's a pretty large p-value. So since our p-value is not less than our alpha, we're going to fail to reject the null. We just don't have enough evidence convincing evidence that the true proportion of households with prime is different than the 46% that was stated at the beginning. And that's how you calculate a one sample z-test for P.